This is part 3 of SPI. The third part of the SPI will show us how we can write the software to implement SPI on the 328. But of course, we need part 1, which is shown above. It talked about the hardware connections between the master and the slave. Now once you make the hardware connections between the two, we can move on to the software. The actual code, the specific lines of code for this, are shown in the book. So what I want to show you here is more of a general outline of what this looks like rather than the specific syntax. I think for us it'll be more beneficial, at least to start that way. So what we want to do first in the software is to do this. We want to say port B 0 0 equals a low. This will select the slave. Now of course someone might say, well, don't forget the DDRB, and of course that is true. If you're going to use port B, you should also set up the DDRB. So we know how to do this. We would set this up so that it has an output as a minimum on bit number 0. Semicolon. Then we need to do the following. You want to make the clock low, and you know what might be easier for us is if we come up here to the hardware, and we're going to do something here. We're going to, this was port B, as you can see, for the slave select, and that's fine. I'm going to bring this out, and then the clock here, I'm going to make this port B bit 1. You see, this will remind us that the clock is on port B bit number 1. We need to do this because we're using a software implementation. So we need to use a port, any port, and any bit of that port to be the clock. So the clock is going to be on this bit. The master out slave in will be the same way. We need to pick a bit of a port. So we're going to pick port B bit 2 is fine, nothing wrong with that. And I needed to go back to the hardware and revise the hardware slightly to be a little bit more clear as to what we're doing and what you need to do. You'll notice that I'm using port B, bits 0, 1, 2, and 3 for the SPI hardware. This is completely arbitrary. You can use any port, any bits that make you happy. So these are the bits that make me happy. And so the PB0 I'm using to select the device. PB1 is my clock, PB2 is my master out slave in, and PB3 is the master in. But I'm not going to use the master in, so that really wouldn't pertain to me. Alright, so you make PB0, let's just call it PB0, a low. This will select the device. You then need to make your clock low, so we're going to say PB1 is equal to a low. You need to, let's see here. I typed in the next line. I wanted to make sure I got it right, so I wanted to take my time with writing this line. It reads as, I have some data I want to send, like the letter A. In fact, you could come up at the top of the code and put that in there saying, okay, data is the letter A. Let's send the letter A to the LCD screen. So if the data ended with this bit pattern, this will select the MSB. And if the MSB is a 1, we send a 1. If the MSB is a 0, we send a 0. So this sends MSB first. Sends MSB first. sends the MSB first. Okay. So like I say, this is going to send the bits out one by one, and it will send them MSB first, LSB last. The next thing you may want, well, you'll need to do, I should say, is to take the clock and raise the clock, and this clock is on PB1, so you say PB1 equals a high. You may need to delay for a certain amount of time because you can't go too fast for the slave. If you go too fast for the slave will miss the bits. So again, you may need to have a delay to slow this down. Alright. Now we need the other 7 bits to also be sent out. So what you want to do is take your data and shift it to the left by 1 bit position. In every line that you see a semicolon, those lines are exact syntax. This line is correct syntactically. Well, we need to repeat this for the other 7 bits. So we need a for loop, and we can put the for loop right here. For loop, and that would look something like this. I equals 0, I is less than, let's see here, that would be 8, I plus plus, curly brackets here, and come down here, put the curly brackets, and let's take a look at this to see if it looks good. Okay, it looks good. Then we need to, after we send the letter, we can stop talking or stop sending bits to the target. And what you'll need to do is to take your slave select, which is PB0, and send that as a high. And that'll do it. So this shows you how you can select the slave, take a letter, loop 8 times, start with your clock low, send the bits out one by one, raise the clock. When the clock is raised, that's when the target captures the data. You then delay, you shift your data to the left by 1, and you repeat the process for a grand total of 8 bits per letter. Well, that should do it. So here's the last part, part 3 of how to work with SPI.